All right, so good afternoon all. I'm Robert Moore. I'm from Embry-Riddle Aeronautical University. I'm a master's in unmanned and autonomous systems engineering. And at this conference, I'll be talking a little bit about my continuation of work from the last conference in redundant uncrewed aircraft systems. So, wait, is it not sharing again? Oh, dandy. Let's see. Your screen. Let's.
There we
Oh,
go. That's good. Thank you.
okay, there it goes. Okay. So in terms of
See here, looks like it's the secondary screen.
okay, so let's see. I need to send. Let's see. No share. Let's try working now.
Yeah.
Okay. Right. So in terms of the presentation conference, so I'll be recapping what my project is about. I will be covering the challenges of essentially doing an informal process of going through the FAA's mean of compliance reliability analysis document for uncrewed systems. I'll be discussing the system architecture, the current system architecture I'm using for the tests, some of the flight testing and the anomalies and hardware failures that I've had. And then Philip and I will be doing a discussion on some of the proposed future architecture designs involving CubeOrange, which I'm using currently, CubeRed, and then a few other different ideas using both types of processors. Okay. Let's see. Is it? All right. So in terms of the project recap, I started this project under a NASA University Student Research Grant, and I was addressing two of the NASA AMRD strategic goals. The first one was a tertiary goal, which was transition to alternative propulsion and energy. But the important one was assuring autonomy for aviation transformation for things like uncrewed aircraft systems, urban air mobility, and such. And essentially what I wanted to do was develop a redundant architecture for beyond visual line of sight, EV loss related operations, or other high risk operations like operations over people. In summary, having a single point failure which can endanger the public or their property on the ground, I deem unacceptable. So essentially what I did was take the CubeOrange hardware and ArduPilot, and then I added Lewis scripting on top to do a switchover logic from primary to backup. So this is the document. It is the means of compliance document for doing a type certificate of an uncrewed aircraft system. It came out around February of 2020. I'm not going to go too in-depth into the whole document, but essentially it gives guidance into my process for how I did my reliability testing over the past year. So with this testing, I was pursuing the rural type certificate hours, which is 3 airframes flying 125 hours each for a total of 375 flight hours. What this does is it gives a good amount of flight data for the reliability of the system, determine what fails on the hardware side or the software side. Essentially, it dictates if the airframe is safe to fly, and if there are issues, how you mitigate them. And on the next slide, it shows some of the required conditions during a flight test. The ones that I follow the most thoroughly are the 3 aircraft. I don't cover the manual such because it's basic proof of concept avionics testing. In terms of the UAS, it's subjected to some of the worst case conditions in terms of in flight. I also have tested some failures like engine flameout and different arrangements. And that's essentially as thorough as I get because I'm not going through that full process. That would be outside the scope of my master's degree. And then here's some more background information. Excuse of all the text, but it really shows how thorough the process is. If you were to go through as a airframe manufacturer, trying to get the type certificate. So this is my current architecture design. So I took a model aircraft, the Seagull model Shot Cub. The reason why I chose this model was it's a fairly simple bush plane arrangement. It's also in the size of a 35cc engine equivalent. So what I've learned from some of my other airframe experiments, the Flex Innovations RV8, which was an electric low wing, had too short endurance. I then, for another project, had a 10-foot wingspan airframe, the Bushmaster 120. It looks like a giant turbo beaver. The problem is that's about 50 pounds, albeit it gets 4 to 5 hours of endurance. That would be within a certain scope, but when I was looking forward, I do want to do things like convert to quad planes. So phase 2 is the standard airframe. Phase 3 would be essentially doing vertical takeoff and landing testing of the redundant systems. If I were to do that with a large airframe, I'd be at 70 pounds. This airframe, I can be under 50 pounds if I incorporate in vertical takeoff and landing hardware, such as a pair of lift booms under each wing. On that note, the airframe did have some hard points to incorporate lift booms where the struts are, so that was another means of convenience. The airframe gets about 2 hours of endurance, which is fairly ideal. Once you get into the 4-hour mark on a single flight, it hurts a little from the operator on the ground perspective. And in terms of hardware, like my prior tests, I had the Cube Orange arrangement with the HERE 3 and the RFD 900X. The PowerBrick Minis, 2-cell LiPos to run all the systems. It's essentially a mix of Cube Pilot and Jetty RC systems. The reason why I went with Jetty was the servos have telemetry feedback and it has central power distribution hubs that you can plug multiple flight computers into. On the propulsion system, I went with gas because batteries get really heavy and expensive when you're doing the long flight hours, such as 2 to 4 hours. And it's easier to essentially gas and go with the airframe. In terms of flight testing hours, I intended to complete a lot more within a year, but many challenges arose. Unfortunately, I did lose access to one of my big test fields where I could go day in, day out. So I had the generosity of a model aircraft field to do my testing, but it was a lot more restricted. Of course, being a master's student as well, you have all the other classes and obligations that you have to do. So within a year to get 31 hours, fairly respectable. And there were a lot of things which also got in the way of building up a lot more flight hours as well. So I know this is a terrible way to do a PowerPoint with blocks of tests. Essentially, these are to show that my airframe that I selected wasn't necessarily ideal. Every flight there is a problem, a part broke or some anomaly happened, so I couldn't crank out multiple flights within a day. So my intention was one airframe do 125 hours, next airframe another 125. Instead, I was chasing so many parts breaking on the airframe and a few other minor discrepancies. There's things like clevises failing and the struts failing, other metal hardware failing. I had a few engine bolts break. I had a few flameouts. It really shows, that going through the flight testing process, depending on the airframe, it can be a real bear if you're trying to get reliability data and everything is breaking. And this is the kind of data the FAA appreciates. We don't have reliability data. So this is a way to document and say, hey, this is all the issues you could have during sustained flight ops. And then to kind of sum it up, picture collage showing some of the different things so you can see metal hardware breaking in the top left. I had an engine gasket let go and it sprayed engine oil all over the airframe. Some of the struts, it was a screw-in arrangement and they stripped out, so I then had to JB weld them together. And then I've had blind nuts just cleanly break on the poor airframe. And I guess this is a better way to show it. So despite those walls of text and the photo collage, this kind of shows over the course of the flights my percentage of failures. Avionics were fairly reliable with exception to a rudder servo dying fairly early on. The engine bolts breaking. I was pushing the envelope on some windy conditions. I did have some fuel exhaustion events where it would essentially be in the loiter, flame out because the turbulence was excessive, and a 100-ounce fuel tank results in fuel slosh. So air bubble, engine flamed out, land okay. But the most was the major anomalies of the struts, clevises, metal hardware breaking. So the good news is our avionics are fairly reliable. It's the airframes that leave a lot to be desired, and that was a total of 31 failures and anomalies. In terms of some of my current testing as well, for my master's capstone, I investigate a line replaceable unit of the avionics. So this goes into one of the philosophies I appreciate, the right to repair. One shortcoming I notice of the industry is many avionics are incorporated into the airframe. If you have an issue with that, the avionics or anything in the airframe, you have to send the whole fuselage back to the manufacturer or have the manufacturer fly out. It would be a lot easier for both the operator and for the manufacturer if you could remove that avionics unit, pop in a fresh one, and send that avionics unit back, say if there's a software or weird hardware bug, because as you know, testing only catches so many issues, and Murphy's Law always comes back to haunt us. All right, so this is the current design. So you can see it's the two cube oranges, and then you have a RC receiver into each, a here, GNSS for each, an airspeed pitot, and then an RFD 900 for each. They go into the Jetty central box, which has, well, for this, I'm using 2 cell LiPos. Depending on what I do, I can have a pair of voltage regulators in line for higher voltage LiPos. And then the advantage of the Jetty, once again, is I take the Jetty Dytech servos and I get telemetry feedback. So if a servo has an issue, I can diagnose it instead of guess, did a servo fail? And then Philip, I guess you can then discuss some of the QBread stuff.
Cool. So, yeah, last year I obviously didn't get to come to the conference. I was otherwise occupied at the Formula One. But I did have the pleasure of listening to Rob's talk and got to have a bit of a virtual chat online on that one. And myself and Rob have been interacting ever since, and it's been great, especially how ArchiPilot brings all sorts of different people from different places together. So, yeah, looking at the redundancy side of things, it's a topic all of us have been talking about for a long time, and it's been a lot of people do a lot of work on that. A core part of that is the work Leonard's been doing with standby mode and all of that sort of work, which without that, it sort of becomes really complicated and messy and a very ugly takeover if you don't deal with some of those I-terms and things like that. So on the QBread, we've gone for a architecture which is basically 2 autopilots in one. So we have a primary autopilot that basically does all the fun stuff like Ethernet and all of the normal day-to-day things, and we have a second autopilot that basically can do the simple things. So if you have something go wrong, you can basically package what Rob had done with the 2 cube oranges into a more convenient package. So basically, depending on how you do it, 2 doesn't give you the ability to start automating the switchover process. So the switchover process in all of this is very much the pilot is flicking to the second autopilot. And that's basically the mentality I think most systems at the moment are going with, of not trying to put too much guesswork into what is flying well and what isn't flying well. And we can add that complexity later down the track. So the idea would be things like a GPS is actually connected to CAN bus 1 and 3. And so, you know, therefore it's available to both autopilots. In the QBread, we have 3 CAN buses to give us access to every single bit on there. We'll go into the architecture of this stuff in probably a few months once we get everything tested and proven. But we've basically got an architecture where the I/O structure is separated from the FMU in a way that either flight controller can get access to all of the I/O that's available. The idea is to try and make sure there's not too many single points of failure. On the QBread, there is one big single point of failure that is still there, and that's the 5-volt rail. There's option for 3 going in, 1 coming out. As we often say to people, a autopilot is not a power supply. Please don't power silly things off your autopilots and manage your power well. But yeah, On this drawing, you'll notice there's 2 cube reds on the one system, and that's sort of an architecture we're looking at moving to. We'll be doing another carrier board for the cube red that actually does have 2 cubes on it, and we'll have the ability to have a completely independent power system on that. However, this is not the only way to do redundancy, and there are other ways coming up that might be a little bit more interesting. You could whack a whole bunch of distributed cubes around the place, which I think is shown in there with 4. That might be a convenient way. Or another way you could do things is things like our Here 3 Plus and our Here 4 that's coming up soon, Here Pro, actually have all of the components on board to be an autopilot. So rather than actually necessarily having everything in the little, vibration isolated box, you can actually potentially be running an instance of ArduPilot on a node somewhere. So you could distribute it completely. This little beastie, which I've probably shown a few of you, is our little CAN bus node that we're sort of working on. It has enough power on it to run ArduPilot a few times over as well. So a concept of a more distributed autopilot system on a distributed CAN bus also can deal with issues like structural damage to the aircraft, taking out a CAN line or something like that as well. And can also be very convenient if you're doing a payload vehicle where you don't actually have a center to the aircraft. So Rob's been doing some great work on that, and so have many people here. And Sid's been doing some great work on the upcoming architecture of the red, and it'll be really cool to get some of that stuff out and ready.
Now, to kind of bounce off what Philip has says in terms of that carrier board should not be used as a power supply. So there was something that came out in the RC community recently from a well-known company called Powerbox Systems, called the Powerbox Royal SR2, I believe. The one thing that really piqued my interest was for its new protocol system, P² bus. Not only did it have the servo outputs, which it provides power distribution to, it had 4 P² buses where essentially one could consider it like, I know this is a bad way to consider it, like a CAN bus node RC equivalent, or better yet, the old S-bus hubs and nodes that you could plug in, except these have telemetry feedback. So I was thinking, well, potentially, I know that this could work. Why not we have something that's both the carrier board for multiple redundant cubes, but also then be a power distribution hub for, say, a giant scale airframe. So we're talking like 25 pounds, 30, 40, 50 pounds, something like a 10-foot wingspan, a larger Group 2, Group 3 UAV. That way you could run something like 16 servos and have that power supply, which didn't burden down a carrier board, and then have plug out auxiliaries for something like in my case, I was thinking a drone CAN power bus. So you could have maybe like 4 different drone CAN nodes, which could provide power to. It could then essentially, you could then have those drone CAN provide telemetry feedback. You could then also control camera systems, maybe have an S-bus out system. So you could then do a few different power distribution like the Jetty CB210. Then also provide power for things like the RFD. That way you could properly power an RFD, or maybe something like an L-site Halo, which is the 4G communications. Then have plugins for something like 3 GPSs, 3 PIDOs, a wide voltage range, a LiPo for like 2-cell to 12-cell. Essentially give you various flexibility for a giant scale system. That way you didn't have to do like a cube and carrier board, followed by a Powerbox system, and then a bunch of other random plugins. Just have it all consolidated into one central hub for simplicity when integrating it into the airframe. In terms of future architecture design, so part of my capstone was this line replaceable unit. So I'm thinking for 25-pound and larger airframes. So right now I've focused primarily on a fixed wing standard airframe, but I've begun the software process and the Lewis scripts for switchover logic for VTOL systems, helicopters, multi-rotors, It does need a lot of refinement. You'll see in the subsequent photo why it needs refinement. And of course, I will admit this isn't a one-size-fit-all. I'm thinking of many different redundant architectures for different airframes. For example, where standalone avionics where you put all that in an LRU doesn't make sense as for, a small 15 to 25 pound airframe. For example, something like a make fly easy believer, if you want redundant avionics, this would be terrible to incorporate. When QBred comes out, it really sizes things down in half and makes it really convenient. In this CAD drawing, I was experimenting with an ODD 44 connector. It isn't an end all be all. I could do servo plugs. I could do other things. You can see the I2C and the CAN bus plugs vertically. You can see the plugins for the RFDs in this experimental case. Because I fly in Florida and it's hot weather, I did have a full cooling fan arrangement just to play it on the safe side. But what I like about the LRU concept, especially when QBred and the dual carrier board comes out, you could then have flexible redundancy like primary backup up to quadruple redundant if you use 2 red cubes. For future flight testing, so right now I'm at a crossroads where I could replace a lot of the metal hardware on the shock cubs and pray that they still stay together, because it would be nice to get that data to say 125 hours per airframe, just to see if I hit a steady state where no more parts break, or if I still have these issues throughout. If it really becomes a headache, an airframe that I want from the get-go, which wasn't available, is the Bushmaster 100. The Extreme Flight Bushmasters are incredibly simple, incredibly rugged. You can gas them up and go, and you can knock out a bunch of flights, and you don't have to worry about parts breaking left and right. And of course, the most important, which I do want to do after the standard flight testing, is an reliability test with quad planes, because there is a market push towards a lot more VTOL airframes. I believe this is the last airframe. Oh, no.
Video's good.
One other thing that I did, come on, let's see. Oh, there it goes, I think. So I did do a little bit of business development as part of my master's. So to provide some clarification on the video, so with the RV8, so the initial roll maneuvers was just testing primary to backup switchover and the backup kill switching the primary. With the severe upset recoveries, that was me putting it in the worst possible case scenario, essentially deep stall, cover and maneuver, and the backup did the switchover, took it over. I had no input into that. And then that's what led, once it proved that it was reliable, that's when I switched to the shock cubs. And as you can see, beginning the VTOL process, but there's still a lot of work to do. There are many different states you have to account for, such as transition between vertical lift and horizontal. What does it do in horizontal flight? What does it do in a standard flight and vertical lift? And that's just the Lewis script just blows up in size as a result. In terms of concluding remarks, this is what I've learned over the process of the past year. The airframe has to be as reliable as avionics. Otherwise, you're going to have a bunch of headaches building up flight hours. Multiple avionic architectures are required, and having industry input and discussion would be vital. And of course, I do need to pursue further flight hours to gain reliability data. Let's see, I think one slide glitched out. I think there's one really important thing. So let me go back. I believe it's slide 3. So I do want to thank Philip Rouse and all of Cube Pilot for all the support of getting me down there. They were essentially my sponsors for this conference, and I want to thank you, Tridge, and the Ardu Pilot community for letting me present again. This is really vital information, and I do like the open discussion of Ardu Pilot to discuss making our system safer so we can essentially do safer operations. I'd like to open the floor now to discussion of some of the different redundant architectures. I know some groups have been pursuing this. If you're free to discuss, let's have the discussion begin.
Can I just ask, Seppo, are you free to discuss? No. Probably not. Okay.
Okay. Yes, Paul?
So the question is that obviously if you have a 2-lane system, probably you always got is how do you know that one lane's fine? Make a switch over and switching over all else to benefit. So I think you alluded to that, and just that's been done by moving triplex with media select, which is mathematically guaranteed to be got us to give first failure. Problem we have with our highly autonomous or automated systems with multiple state machines at multiple levels is that you can get a situation, and replaceable, where one flight computer is trying to fly the hour, and the other flight computer is trying to fly to waypoint 3, and the other flight computer is trying to fly to waypoint 7. Or the integrators on all 3 lanes to diverge, and then you switch over and you get bad data. So that's in part being handled by cross-level database. Look, those key items that it remains keeping on. But we need to include in our architecture, and that includes our software architecture and our hardware. We need a low latency data link. Those 3 flight computers or 4 are really fully in connection, share the synchronization data between us, and we keep it synchronized. So we don't end up with a lane switch followed by an aircraft that's flying to waypoint, while after the other suddenly try to fly back up and go to waypoint 7 because
Exactly.
Yeah, I'm not quite sure what you've got at your comment on what links you've got available at hardware level for these nodes to talk to each other, and sending data across for the critical process.
Yeah. So the primary link at this point will be CAN, and Sid's been putting a lot of work into getting CAN FD across, which speeds things up dramatically there and gives us a much heftier bus, and we have multiple CAN buses running. On the Cube Red, we also have a serial bus between the 2 systems, so that they can do what needs to be done outside of all of that.
And even that we can actually run it like my like we want to run it 2 megabits, stuff like that. Because the same block and same sort of block structures, people will see the connection data for the passes. So that's sort of data, PD plus serial that gives you a lot of that fishing and
because
but I think the implementation of the synchronization itself is more of an architectural question. What I think that is more of that.
Because the reflex of synchronization data.
Yeah.
One state, and which means we need to have a process of negotiated state change for the 3 nodes.
Yeah.
Then you've got your traditional integrators.
Yeah.
Which you things like controllers, your controllers. And then you've got things like states, things like that, which if one gets read, if you get
The way I designed standby mode was it's basically follows everything on so it takes all the same inputs. So if you change mode, change to loyalty, it'll follow those modes, but internally it prevents the item build-up of position controls, attitude controls, and all that sort of stuff. So the thing is, so if you actually are, if for some reason you have a failure, that means that the autopilot that is not selected to fly the aircraft is actually flying the aircraft, because you've got a failure in your servo outputs, in your servo output selection circuit. So you're actually locked on
That's another objection decision.
that's right. Yeah. So so I wanted to ensure that if you failed there, that even though it was the unselected autopilot with its iTurn 0, it could continue to fly the aircraft. It's just that it would tend to have a bit of lean error and that sort of stuff here and there and something. However, what that relies on is, as you said, if you're in an auto mission, you've got both these two autopilots running the same auto mission. However, the autopilot that's not controlled may think it didn't quite reach the waypoint yet, so it may not trigger the next waypoint. So that's where the overriding thing needs to actually pass that information.
State changes, wait.
That's right. Yeah.
So each element, each node. So I have an intention to change it, make this change.
That's right.
And it wouldn't go like democracy. It would wait until somebody else, another, and until the majority of elements agreed with it.
Well, that's
then you make a change. But then if you can't get agreement between three and you've got unparliament effect, then you revert back to a default behavior, which is a safe fallback. If nobody can agree, then you're going to agree to do this.
well. Then you're actually part. That's a whole level of complexity again. There.
This is not something that's
Yeah.
I think baby steps are important in this too.
Right.
The ability to manually switch between this and this. In the examples that Rob used, the aircraft is flailing around in the sky and the pilot goes, oh dear, this doesn't look good. Flick into something that puts it into a mode that is safe. And that mode could be simply loiter, and that autopilot might do nothing else other than hold it in position until you figure out what's going on. So keep it safe. Keep it simple to start with. And all of this stuff, we definitely want to get there, but step by step by step.
The point I was making there is the state you're starting to talk about passing around there are actually internal navigation decision-making mistakes, in which case a single autopilot can no longer make a decision that
That's
it's.
what you don't do this one. Essentially, you've got three pilots in a cockpit.
That's right. Whereas the system that I envisaged with the standby mode, all that is being done internally by one autopilot, and then the others are kept up to date with that in case they get switched.
It's not guaranteed by operating on any single pilot. That's where we play the scene.
Right.
Yeah, it depends. It depends what your outcome is. If your outcome is to finish an auto mission, that's a pretty complex thing. If your intent is to stop, just be safe, then that's a good starting point.
Right, and to
about another level above.
That's why it's a bit from operating this start phase.
Right, and just to provide some clarification in terms of what my system does currently, so the backup flight computer through the Lewis script sees the exceedance and parameters, kills the primary. Goal number one is to auto level the airframe and get it to within a cruise speed. So if it's overspeeding, it slows down. If it's stall, it speeds up. Then it goes into either an autonomous loiter near the launch point, or it RTLs. So just starting with the baby steps. As you said, continuing the auto mission, that's a whole another layer of complexity, which,
Yeah.
Yeah.
So we define, we just need to be clear what we're trying to do and what we're not trying to do. Because
right.
the concept is this is a part of operating system where we can continue the mission. That's very different to a system where we get it down in a safe way. Finish the mission in a safe way.
I guess, do we have a redundancy systems thing in the Discord? Maybe the next logical step is to say this will be our phase 1, 2, 3, 4. Start simple, build it out, because right now primary backup it's better, but it's not perfect to say a triple or quadruple redundant. And then we slowly want to make that more capable, like you said, as time progresses.
Yeah, so there's a reason we actually went for double. We were originally going for triple. The reason we went for double is because baby steps.
Because you do switch out, which you
Yeah.
still can't use the aviation industry, and things like that.
Yeah, exactly.
I guess this is a bit into the weeds. If I added my scripts on top of QBread, could it then do it automatically instead of a manual pilot does a switch?
And that's that. There's so many cans of worm in that one that it's many more talks and many more meetings, I think.
Yeah.
And this is in continuation with the same. This redundancy, does it work in the master slave mode? Or I just wanted to know how with the handshaking it done between the two flight controllers?
So in the current setup, the second one would be in when it's standby mode. Basically, it would be sitting in standby mode, and you would say, this one's in charge, this one's in charge. That's step one.
Well, that's only for the multi-brain code. So the plane code has a different set of.
Yeah.
Yeah, there are differences between the multi-rotor and the plane issues as well. So
in case of copter, I'm asking, suppose we are having two flight controller. Okay, so they are working in redundancy. In that case, what is the handshaking will be done within the two? Because during runtime, both will be both will be having the same state, but each IMUs or the peripherals which are connected, maybe they may be reporting the different data. So how is the handshaking then between the two flight controllers? And does our autopilot, does it support this redundancy?
I think, Leonard, do you want to answer that one?
So standby mode takes care of offsets in attitude, position between the two autopilots. So one autopilot thinks it's flying here, and the other one thinks it's slightly canted off and a few meters off. This autopilot's going to want to make corrections. This one's happy. This one's in control. That's why it's happening. This one's not in control, so it's by default not getting what it asked for, and it's not going to be happy. Standby mode basically says, we know you're not happy exactly, but we're going to remove your ability to build up those iTerms and integrators. That would mean if we switch to you, you have a huge step. And so what happens because those are all kept small, the aircraft starts fighting from the moment you get that autopilot starts fighting that offset from the moment you switch to it and builds up then, rather than it has this massive built up iTerm that it can't do anything.
Yep.
And so this just basically allows you to, so that all that internal state is sort of handled inside. And then the stuff, the only time you need to sort of synchronize then is if you're doing the more advanced thing, like keeping the two navigation controllers on the same leg of a waypoint and that sort of thing.
Yep, and to kind of bounce off what you said with the whole iGain thing. So in the early days of the RV8, I made the mistake to put both in auto for RDUplane. The iGain ran away, and then all hell broke loose when it deflected controls to Maxon, and she went essentially, out of curiosity, is there a standby mode for RDUplane, or can it be?
Not that I'm aware of.
Okay.
I did standby mode for Copter a few years before because I knew people were going to start wanting to do this sort of stuff. I was hearing people sort of become interested in this. And basically, I didn't want to be dealing with people crashing aircraft. So I built this little state in there that basically made everything safe so that people like yourself will come along and then start building all the issues on top of these things and start to produce the specification to take it to the next level.
So in terms of that, I did do a bit of limited testing and ground testing for Copter. The good news is that does work as intended. In terms of what I'm doing with plane right now, I'm keeping it to the manual flight mode, just so nothing gets deflected. Buzz, you have a comment?
I was just going to say, for plane, you might be able to use lure to zero your iTerms.
Oh, maybe we.
I think the work Leonard's done on Copter really paves the way. So it's a matter of someone.
It is effectively, sensibly, like there are a whole heap of things that are effectively integrated. Some of them are more subtle than others. There are the obvious items, but there are a lot of position velocity controllers that actually are effectively integrators that need to be, that the maximum positional errors need to be limited and things like that. So, yeah, so there are the easy things, but planes also tends to be a bit more point and shoot, and it's navigation too. So you can probably get away with it doesn't have the tight position controller. It's got cross track, and it'll probably handle a cross track arrow being kicked in quite cleanly anyway. So you can probably get away with a simple Lua script just keeping those items set to 0.
Sure. Yep.
So when we say the redundancy of avionics, do we mean the redundancy of sensors or the microcontroller?
In this circumstance, we're talking about microcontroller. Normally, for the last few years, we've obviously been talking sensors. Cube's been triple redundant on sensors, but the single point of failure has always been the microcontroller. And that could be a mechanical failure, it could be an electrical failure, it could be a software failure. Lots of potential causes for something like that to happen. So
did we encounter any microcontroller failure in this, and were we able to recover from it?
So it wasn't a microcontroller failure per se. So the DA35 has a lot of vibrations and it does beat the airframes up a little bit. So one of the flights I had, the primary flight computer, the cube came slightly loose because the screws vibrated. Fortunately, flipped to backup, land no issue. Carefully removed the primary, tightened things back up, did some vibration mitigation measures, and went on my way. So more of a airframe induced hardware issue, but not the hardware failing itself. Like that was a user installation error, not a physical hardware failure.
George, I believe you've got some tests and things you can be very nasty to flight controllers if you want to be as well, don't you? We could do horrible things in flight. So obviously, when we get to that point, yeah, we'll be very mean to the thing. Yeah. So,
Okay.
Cool.
Yep. Yes.
Just a comment, if I may. So if you split up your testing across 3 aircraft to achieve the FAA's 350.
That was the attempt. So I'm still on airframe number 1.
But my comment was going to be that very sure that the rules are that it has to be on 1 aircraft because you're trying to achieve 100 hours.
The FAA's requirements are actually a minimum of 3 aircraft to achieve
Right.
the hours.
And
So that's
though
actually one of their requirements.
the airframes do have to be set up identical,
Yeah.
so same firmware, same hardware. So if I go back,
So your goal was to achieve 375 hours on 3 aircraft, not 375 hours between the total of 3 aircraft, is that correct?
correct. So it's 125 hours per. Yep. Yep. Any further comments? Yes.
So this is in continuation with the previous question only. Since and told that there will be standby mode. So when it switches over to the other flight controller, when it switches over to the other flight controller, so that switchover time, whether that copter will survive for that much of time.
It's instant.
Yeah. I'll put it this way, I mean, we're throwing pictures out of horrible things tumbling and they survived.
Yes.
The easy stuff.
Yep.
The 2 red cube pilots, are they identical? Are they different as similar in sensors and architecture?
If we run 2 of them, the 2 will be the same, but there's a bunch of different sensor architectures within the one. There's 5 IMUs in the one. I will say they're all InvenSense. But we have 5 different sensors in there. And there's less sensors on the secondary controller to the primary one. So that there's definitely going to be a difference of behavior in there because the secondary one doesn't have things like the Ethernet and a few other. It doesn't have an SD card. It doesn't have USB. It doesn't have all this other stuff. So there will be a difference there. There are some other architectures we're toying with, but this is an ArduPilot conference, so I won't mention PX4 on one or an ArduPilot on another. I'm not sure that would be appropriate.
Just curious, if they drive the requirement.
Sorry, what was that?
If they drive the requirement for the cubes to be dissimilar, like.
The FAA want evidence that the thing's not going to fall out of the sky.
Okay.
It'll be up to us to figure out how we do that if we decide to go for a certification.
The problem by the sufficiency.
Right. And I,
Define the problem.
right. And I will make a fairly big disclaimer. Like I said, I'm not formally going through the process. As you can see, this is for the airframe and not avionics per se. I don't, besides the DO standards, I don't think there's certification for avionics.
The FAA, CASA, and many others are sort of going to different methods of proving reliability. There's definitely there's definitely benefits in some testing and stuff like that, but in different ways. But we've really got to get them defined, and it's really up to each individual group. We've got multiple companies around the world that have already managed to get FAA certification with cubes and ArduPilot and stuff on board. So up to the end user really to actually define that and finish that off. We just give them the tools.
Thank you.
Yes.
So operationally, the flights, how did you perform them? Because I noted that the times weren't really different. So did you perform the same mission over and over with automation, automatic takeoff and landings? Or were you doing something like that?
All right. So with the Shock Cub, I prefer manual takeoff and landing, but I was doing autonomous loiter. That was due to a constraint of being on the RC field. It's under a letter of authorization in controlled airspace. So I kept it within a fairly confined area just to loiter to play it safe.
Yeah, I was asking this because the repeatability of and the stress, mechanical stress over, pilot errors, landings or something. Or, the limitations that come with automatic landing systems. Yeah.
Right. And I didn't install things like LiDAR stuff so that I had a financial constraint under my grant. I'd also done a change of scope to go to the gas airframes over 3 RV8s just to get the endurance. So I've essentially run out the budget within my research grant. So when I decide to pursue the next phases, I would need to seek capital to, do a VTOL conversion or change airframes or such. But fortunately, my university has really great avenues for pursuing funding. Yep. Yes.
Yeah, we able to close the feedback on whether secondary controller like a as well.
Oh, sorry, can't quite hear you. Could you speak up, please?
Were you able to confirm like when the secondary flight controller took control, or did this happen through the switches?
You said close.
Can you confirm? So I'll just translate from British to Australian.
Sorry, my hearing is a little shot. Gas airframes are terrible on the
I think he's got a microphone now, so. No, microphone not. No, sounds like.
Yeah, just.
He just wanted to know if you could if you got feedback.
Oh, yes, I did. So the Lewis script says, so essentially I have 2 things. So it says backup has taken over, but the nice thing about the system is if I want to cycle through multiple failures at once, I can then re-switch back to the primary. So I can say primary reactivate or backup has taken over, or I can just do it via the switch. So the pilot can do it or the system can do it itself. And it always confirms, assuming that I get an accurate RFD downlink. Yep.
The aircraft that was selected, it's got lots of parts on it, obviously, and parts of what things go wrong. I was pleased with a 5-minute run with one electric motor, big battery pack in it, and the 3 servos. And that they're the bottom system, you can get them to fly, 2 hours, and they're very reliable.
Granted, it's a little simple. So part of the reason I chose this airframe as well is it's 1 servo per surface. So if I had it, so for example, I had a single servo failure, it didn't take down my whole airframe. So From the last talk I gave an example of a single elevator servo on that airframe. That servo burned out and then went the airframe. So this is a good proxy for, a servo per surface. So even if one failed, like I did have one fail, I could still fly it back.
Well, one form of reliability right now.
Right, so it's essentially, you can keep it simple, like a quad rotor or a single servo per surface line simple, or you can add redundant elements to a point.
Yeah,
I
I would
always a
agree with
trade-off.
that. There is a tendency to tend to want to have the fanciest test equipment out there. A good old Bixler 2 or something like that is a very good test point. It's
That's fair.
not quite as pretty, but yes.
And for what it's worth, there is a group out there who does have large bush planes for some of their flight ops that they've converted with great success. Initially I would have done the Bushmasters, but things changed and then I went to the Shock Cub. So that was a design decision I made. Yep. All right. If we're closing out, I do want to say one final thing. Last year I had 14 companies reach out. I want to thank those companies for reaching out last year. Some of them I've maintained constant talks with, which have given support and ideas. Unfortunately, there were some that sent emails, which I sent emails back, and I'm not sure if it went into the void or such. So before I fully close out, just on the off chance that there's some kind of email issue or such, so I have 2 email addresses as a primary and backup. Feel free to reach out to me again if you never got a response back, and let's see if we can get communications going. Also, LinkedIn is a good way to find me as well. So thank you all for your time and thank you all for the discussion.